So the mean with this is going to be the sum, as you know, divided by the number of data in the set. So, oh, here we go. 9 plus 1 is 10, and then you have 10 plus another 10, 7 plus 3, and then you have 20 plus 5. So 25 divided by 5 is 5. Okay? So the mean for set A is 5. All right? And mean can be represented by x bar. So as you know, these are all points or data points for your classes. Those are your x points. And x bar, with the little line on the top, represents the mean. So the mean for the data set for class A is 5. And we're just going to put A there, but let's find B. Okay, so the mean for B. So again, we're just going to combine this. So 4 and 6 make 10. 5 and 5 make another 10, plus the 5 in the middle, so that's 25 again. 5 pieces of data, so we get x bar is 5. They both have a mean, so that's kind of weird, right? They both have the same mean, but the data sets vary widely. So if you wanted to talk about the data or the classes, you would probably not use mean because they're the same, and obviously the class data is really not the same. So it's kind of amazing how they can both have the same mean, and yet, you know, that doesn't really represent what's going on. Just like if you take salary figures and, you know, you take the salary of a high earner, someone earning like $300,000, and the rest of the people are earning like $20,000 or $30,000, and you average it, it'll still seem like, you know, the whole group of people are earning pretty well every year. But in actuality, only one person is. The rest are earning under $30,000 or $40,000. So sometimes the mean is not the best way to represent your data. Hence, we're going to look at median. So median. The median for class A and the median for class B. The median is just when you line up everything in order. So already you have the data already in numerical order, right? 4, 5, 5, 5, 6 is in order. If I gave them to you mixed up, you'd have to put them in order for you to make this work. And then same thing here, 1, 3, 5, 7, 9. To find the median, you just, I like doing the chopstick method because I'm Asian, so just go, you know, and then whatever's left in the middle. And it's nice here because we have a nice odd number, so we're going to have just one median. So then again, and then 5. So that's strange. The median and the mean are both 5. So just like I gave you that scenario with the salary, it doesn't really tell you much because you know, you can tell there's like a big difference between the classes. They both have the same median and a mean, but it doesn't really give us the most. So another thing you can do is look at the MAD. MAD is mean absolute deviation. Okay, so to do this, you need your mean, obviously, because that's the M part. And you're going to need a little absolute value in a minute. So to do this, I like to make a chart. So, and you have to put your data points. So for class A, my data point is my x values. All right, so what's my data points? I have 1, 3, 5, 7, 9. Okay, class A. And then we're going to see how much each point deviates or is away from the mean. And we said we already calculated the mean to be 5. So we're going to just subtract. All right, so x minus x bar. We know the mean, which is x bar, is 5. We know the data point is x. We're just going to subtract and see, you know, like the difference, like how far away it is from that mean, from the average. So 1 minus 5 is negative 4. 3 minus 5 is negative 2. 5 minus 5 is 0. 7 minus 5 is 2. 9 minus 5 is 4. Okay, and now we are going to take the absolute value of it. So whatever was in this column, we're just going to make it positive. All right? Are you absolutely sure? Yes, I am. I always tell my students, make it positive. So negative 4 becomes positive 4. Negative 2 becomes positive 2. 0 becomes 0, 2 is still 2, 4 is still 4. And then that's it. That's my chart. It's beautiful. Okay. So now what do you have to do? We did the mean part. We did the absolute value part, the deviation part. Now you're going to take the mean of this. And I mean it. It's not fun, especially if they're hard numbers. So this is actually kind of easy. 4 plus 4, 8 plus 2 is 10, 11, 12. So you take the mean of all this, 12, divided by how many data points? 5. Okay, and I never let my students use a calculator, so I'm not going to use them either. So 5 goes into 12 too. Sorry to bore you here. Okay, so 2, bring down this. Oops, it's a 4. 2.4. All right. So for class A, mean absolute, my MAD for class A is 2.4. All right. So I'm going to do the same thing now with class B. I'm just going to make it easier and just erase. That's the beauty of erasing. I'll have to redo the chart. Okay. Oh, different data points. So now we're going to look at the class B data points. We have 4, 5, 5, 5, and 6. So again, remember what we had calculated before. The x bar was also 5. So we're going to do this. 4 minus 5 is negative 1. 5 minus 5 is 0. 5 minus 5 is 0. 5 minus 5 is 0. 6 minus 5 is negative 1. And then we take the absolute value of everything. Okay? Absolute value of negative 1 is positive 1. 0 is 0, 0, 0, 0, 0. Absolute value of negative 1 is, I'm sorry, I made a mistake already. 6 minus 5 is not negative 1. Sorry about that. All right, 6 minus 5 is positive 1. Positive 1 is just 1 when you take the absolute value of it. Okay, so now we find the sum again because we want to get the MAD for class B. All right, can't believe I made that mistake. Sorry. All right, so the sum is easy. 1 plus 1, 2. How many data points? 1, 2, 3, 4, 5. 2 divided by 5. 2 fifths, 40 cents, 0.4. Okay, we're done. All right, so let's see. The MAD, mean absolute deviation for B, is 0.4. Let's say 0.4. All right. So now this brings us to our quick discussion. All right, so here's my answer. And then you can just make your little, discussion on it. Mean was the same, median was the same, ranges were different, and basically mean absolute deviation is talking about like those differences, those range differences. Amazing how class A varies. Mean absolute deviation deals with the variety or the variation of a data set. Okay, so 2.4 means it's varying a lot. That means one kid is reading 9 books, one kid is reading 1 book. You have a lot of variation. You have a big range. Okay, for the second class, the MAD is only 0.4, which means there's not much deviation between the students. So I guess from a teacher standpoint, you could say something like, well, this class, they're all at the same level, whereas this class, you have like high range, low range. You know, you're going to need to fill a lot in that modification accommodation section of your lesson plan because you have lots of differences here. Okay? And that's all this is. Isn't it, Matt? Okay. last, not least, let's quickly graph this on a line plot. Okay, so line plots, students in 5th grade have to know how to do the line plots, and they're really easy. You label it Class A, the number of students, or you can label that too, number of students. Nope, wrong. Number of books is what we're labeling here. They read 0 books, 1, 2, 3, 4, 5, 6, 7, 8, 9 books, 10 books maybe, make it look good. And then anytime you see that data value, you put an X, which is strange. Why don't they call it an X plot? They don't, they call it a line plot, maybe because there's just one line, I don't know. So here's an X, and then Class A read, one of them read 3 books, one read 5, one read 7, one read 9. Again, it's just a nice depiction of like the beauty of, you know, the distribution. Okay, and then Class B, we again have, we'll just do it like that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to put an X at our data values, so 4, 5, 5, 5. So this is where we start stacking them. We have 3 students who read 5 books, and then we have 6. So see how, like, again, you can kind of see the variation is wide here, right? Mean absolute deviation. And then here it's all pretty clustered. So I guess that's kind of good to have things all clustered like that. Okay, if you're not talking about diversity. Now, I think you also were asked to do a line plot. No, that's the line plot. Let me just check real quick. You had to do the box and whisker plot. Okay, so with that, that's where you need to know where the median is. So there's actually a couple ways to do this, but for the box and whisker plot, you could put 1 as your minimum. Okay, so the first point is your minimum. Your last point is your maximum. So that's 9. Your middle point is your median, right? But as you can see, what was our median? It was 5. So I'm just going to put it underneath to make it easier. That's 5. Okay, and then you take the median of the median. So here's your median, here's your minimum. What's in between it? Your other median is 3. I'll put that here. And then here's your your median. And here, it's also your mean. And here's your maximum. And what's in between that, the median of the median on the other side is over here, it's 7. And that becomes your whisker. Okay, those are your whiskers. And here's your box. I know it doesn't look very straight. Okay. Oh, very unstraight, sorry. I'm at an angle here. That's your box and whisker plot for Class A. Okay, so this would be quartile 1. I'll just put Q1 so you know. Your first quartile, here's your median, your second quartile, and then your third and fourth quartile. Okay? Alright, so you don't need to really do that. Don't worry about that. Alright, and then over here we'll do the same thing. So now, this is interesting. How are you going to plot this? You would say your minimum is 4. Your maximum, oh, this is going to be funny. And I would just, that's going to be different. Okay. Minimum is 4. Maximum is 6. I wonder if it's going to look like that. Okay. This is good enough for me. I'll take that. Okay? So, and obviously it's not height we're dealing with, but 5's in the middle. Okay? So, not the best data to do box and whisker plots, I apologize. But I'll accept these as answers. Your first quartile is towards the left. You call them lower quartile and upper quartile if that's easier, right? So like when you're talking about quartiles for examination scores. You know, oh, I'm in the upper quartile. That means your score is like towards the 25%, right? Basically, we're getting fourths here, right? So your score would be in the upper areas, hopefully. Okay, very good. I hope this answers any questions with that number 15. Please email me if you have any questions about what I did, and I'll accept work like this. And have a great day. Bye-bye.